Okay, let's just go back to question 1 and have a bit of a look at that. So we've got the graph of y equals the square root of 8x cubed plus 1 and the graph of y equals the square root of x cubed plus 1. So let's write each graph in a similar format. So if we rewrite the first graph, y equals the square root of a single term all cubed, so 2x all cubed plus 1, it becomes the y dashed equation equal to square root of x dash all cubed plus 1. So in this case, we're starting with the graph on the left, ending up with the graph on the right. So if we equate all the expressions, we can see pretty clearly that the y values are the same, y equals y dashed, and the 2x term has to be equal to the x dash term, all right? So remember, I much prefer to have my transformations written as x dash y dash becomes, and then whatever they are. So really all I like to do is just try to determine what x dash and y dash are, and in this case, x dash y dash becomes 2x comma y, and a 2x simply means we're multiplying our x coordinate by a factor of 2, which means we dilate by a factor of 2 from the y-axis, which is a. Flowing on, the point 4, negative 3 lies on the graph and it has some transformations applied to it. So the point 4, negative 3 is translated 4 units vertically up, which means we add 4 to the y value. So that becomes 0.41. And then we reflect it in the y-axis. So if we reflect in the y-axis, it means my x-coordinate change. So then that becomes a point negative 41, which is a. Graph of 2x cubed is translated 2 units left. Okay, so again, I prefer to go x dash y dash becomes, right, 2 units left makes it x minus 2. Divided by a factor of a half from the y. So if we're multiplying from the y-axis, it means the x-coordinate gets affected, and then translated 1 unit down, which means my y value has 1 taken off it. Actually, let's make that a different colour. Yeah, so if I equate x dash becomes or is equal to, I might write it as a half x minus 2, y dashed is equal to y minus 1, rearrange, I'll get 2x dashed plus 2 is equal to x, y dash plus 1 is equal to y, and substitute that into the function that I'm interested in dealing with. So I'll get y dash plus 1 is equal to 2 times x squared, which is 2x dash plus 2. Then we have y dash is equal to 2 outside of 2x plus 2 all squared minus 1. So I get B. We might need to check that because the answer I got given was C. But anyway, let's move on. The image of 0.35 after reflection, translation. Okay, so again, we've got the 0.35. What does it become? A reflection in the x-axis means the y value changes sign. A translation of 2 units in the positive direction, which means we add 2 to the x value. And that gives us D. All right, so let's sort out the transformations. X dash y dashed becomes reflection in the x-axis, so that becomes negative y. Dilate by a factor of a third from the y, so that's 1/3 x. Translate 3 units left is subtract 3. So x dash becomes 1/3 x minus 3, y dash becomes negative y. Tidy up and get x equal to, so x will equal to x dash plus 3 with 3 out the front, and y will equal negative y dash. So if we put that into our function, we'll get negative y equals f of x, which is 3x plus 3. Finds then that y will equal negative f of 3x plus 9, which is C. Graph shown right. Following graphs, the following transformation. So again, I'm going to go with. Well, we can really get it done in this way, can't we? So the negative. So almost. Let's sketch it in 3 separate. Okay. So let's do the negative. Negative flips everything upside down. So we've got a turning point down there. That's still going through -2. It's still going through the origin. So that's sort of like that. So that's negative f of x. Yeah. The 2 out the front multiplies all my y values by 2. So that's still at 0. That point here goes higher. This point here goes lower. Something like that. And plus 3 inside the function takes it 3 units to the left. So that point at 2, the x-intercept at 2 probably is now at -1. The x-intercept at -2 is probably at -5. The origin is at 3. And so we're going to have something that looks a little bit like this. So there's only one possible graph really that suits that, and that's E. So we didn't need to know the specific turning points because there's only one graph that suits. All right, which of the following could be the order transformation applies to g of x? Okay, this time I do want to. Which of the following? Okay, so let's work out. So let's write. So if I rewrite, I'm going to have y equals g of x and negative y dashed equals g of 5 minus 2x dashed. Yeah, so if I equate expressions, I'm going to have y is equal to negative y dashed, x is equal to 5 minus 2x dashed. So let's get x dash y dashed is equal to, because that's how I do my transformations. So y is simple enough, that's just negative y. So if I work out what x dash is going to be equal to, it'll be 5 minus x on 2. Yeah. So let's list the transformations. I've got to reflect about both axes. And then for the x, I could either translate by 5 and then dilate, or I can write it as, since everything is written as 2.5, I'm going to think of the x coordinate as being 5 on 2 minus x on 2. Okay? So I need to reflect about both axes, and I want to go dilate by a half. I've got a half from y, reflect in y, and 5 on 2 units in a positive direction. So we can look for them. I've marked C as the answer, so to see if that ticks it. Reflect in the x, reflect in the y. We said that. Translate 2.5 units. Oh, I'm on. 2.5 units right. I guess I don't like the fact that it says a factor of 2 from the y-axis. I want to go a factor of a half from the y-axis. So I'm going to make it option A, I reckon. Question 8, we've done a few of these. I'm going to start with the 0.35. I'm going to reflect it in the x-axis, which makes the y value negative. Reflecting it by translation of 2 units in the positive direction into the x, so we're going to add 2. Is this a repeat? It sounds like a repeat. 5 negative 5 is D. Okay, so the last one here we can approach in a couple of ways. Let's just get some ink. All right, my preference, so the original equation y equals x squared becomes y dashed. I'm going to bring the 2 across, x dash minus 3 squared. Yeah, old equation, new equation, so now I'm just going to equate. Y is equivalent to y dashed on 2. X is equivalent to x dash minus 3. All right, so now if I rearrange, I'll get y dashed is equal to 2y. X dashed is equal to x plus 3. So my new coordinate, x dash y dashed, is equal to x plus 3 2y. So that's 3 units to the right and 2 times from, if I multiply the y value by 2, I'm in from the x-axis. So 3 right and 2 from the x is D, as we've got marked there. Alternatively, you can just use your function notation. We know that the transformation, if you like, is y dash is 2 times f of x minus 3. So with 2 out the front, dilate by 2 from x, 3 inside the bracket, 3 units right, and we're going to end up at the same point, aren't we?